Thank you. All right. My name is Matthias. I'll talk about tf.Transform and Apache Beam for doing pre-processing of machine learning pipelines. So maybe as a first, just to get to know you, like who is using Python, Apache Beam? Okay. And is this like mainly Python, Apache Beam, or mostly Java and also a little bit Python? The question to raise your hands would be like, is it mainly Python? Yeah. Okay, all right. Okay, good. So yeah, this talk is only about Python, Apache Beam. So that's good to know. So basically, I think it's like a really like the killer features for Apache Beam if you want to use it. And if it needs to get more and more involved with the Python usage, it will mainly come from the TensorFlow or machine learning pipelines. So that's what I want to talk about today. So basically, it has 4 points. I'll just want to start about machine learning in production, then do an introduction on TensorFlow Transform, what it is, how it works, give a concrete example, so you have like really the code snippets to follow, and then finally I have some time for questions. Okay, so yeah, basically I think the people who have been working on this, if you want to work on machine learning, you want to work on specifically the models, and that's the typical expectation of how it looks if you're actually running something in production. They have a lot of model work and a little bit of other stuff. There's a lot of other stuff, but like it's a little part of your work. In practice, it's more like this. You have like a lot of other stuff, and you have like a little bit of time to do the model itself. And that's a bit the reason why basically TensorFlow Extended was introduced. This is a figure from their paper, and this paper shows like, okay, in the TensorFlow or in a machine learning problem, for putting it in production, you have a lot of problems, and there's a lot of elements to it that can be reproduced, can be reused, and basically they trying to open source a lot of these elements in there. And as you can see, I'm just showing the picture of what has already been open sourced. You have the TensorFlow Transform, the trainer, TensorFlow model analysis, and the TensorFlow serving. So you have all of these, and a lot of these contain the Beam logo, meaning that basically it's using Apache Beam underneath it. So it's pretty neat. And today I'm focusing on TensorFlow Transform, and this is really the part that helps you do the feature transformations on the pre-processing part. So what is TensorFlow Transform? It's basically a library for pre-processing TensorFlow pipelines. And the main benefit is it allows you to do it on a structured way on big data sets, and it avoids the training serving skew. So that's basically, if you have seen the first blog post, this is the picture you always will see. And my main goal is that this picture is totally clear for you at the end of this talk. So if you have any questions left, please raise them. So yeah, that's the main idea. So why is this very relevant? So typically, if you're doing anything, you have to work with a lot of big data sets, and you're using some tools to basically train your model, which is the same underneath. And at serving time, you have your very small requests, something like an API, that questions this model. The problem is that you probably have some different codes in between those, which means you have to also you have 2 languages sometimes that you want to use to do stuff. You have to replicate everything, so this introduced this skew, basically meaning that it's not always the same what you're doing during the pre-processing for training versus inference, which causes a lot of issues and basically errors that you cannot really explain. So that's what TensorFlow Transform helps you with. It's basically some way to do this pre-processing for the training and for the inference using the same code. So that's the whole idea. And how it works is basically you have 3 steps, and it looks a lot like the scikit-learn fit and transform. For the fit step. Basically you have the 2 steps. It basically first go over the complete data sets. So you have this analysis step, which does iterates over the complete data set and calculates some averages of some numbers that are needed to basically do the pre-processing. And then next you have the transform step, which actually does a transformation of your data to the format that you want. And it uses TensorFlow graph to do this, which is constructed in the previous step. This again runs over the complete data set. And with this TensorFlow graph that was used for the pre-processing, you can also use it at serving time. So that's basically the main idea, that you're using the TensorFlow functions, the TensorFlow ops, to do this kind of pre-processing. You use the same ones during step 2 and step 3. And additionally, the analysis step and the transform step, you don't have to do any specific coding for the two, because you can use the same pre-process function. So that's like the two concepts, I think, the TensorFlow graph that gets constructed and the pre-processing functions that are used to do the transformation and the analysis. So if you look a bit deeper in the pre-processing function, that's like a minimalistic example of what could be done in such a function. So this pre-processing function defines the outputs based on the inputs using some ops or functions, which are either TensorFlow transform functions or TensorFlow ops. So here we have the three inputs, x, y, z. And the idea is to get some outputs, a, b, c. And you need to do some steps in between to reach that goal. So the first, if you look a bit closer to the steps, basically we want to try to construct a, the output a. Then the first step is the normalization of x. So this means that we need to, during the analysis step, we basically have to calculate the mean and the standard deviation in order to do this. And then during the actual transform, we just use those numbers to actually do the normalization. So that's shown on the right. Then next we multiply this by y. So this is just some multiplication, which is just something you can do in TensorFlow itself. So it's not something that we need to use TensorFlow transform specifically for. It's basically just a standard function. And then finally, we do the bucketizing of those two. And for this, we again have some analysis that we need to do in order to define the quantiles or to calculate the buckets. And with these numbers saved, we can then, during the transformation, use those to actually do the bucketization. So at that point, we have calculated A. If we want to calculate B, this is here just defined as any random TensorFlow function or TensorFlow op. So there's a lot of those available. So if you just go and you can look for them, what's all available, you can just define it like this. Just do this with this input, and you get the expected output. Or you could specifically use TensorFlow transform functions that can do a little bit more. So in this case, this tf.T n-grams to calculate the n-grams over the strings. So that's basically like an example of how this graph is constructed using the preprocessing function. And if we look a bit closer to what the analysis means versus the transform means, is basically all the stuff in orange that you need to analyze a step for. So basically, you need to full pass over the complete data set to calculate these mean, standard deviation, the quantiles. You cannot do it one by one. You need to do it over all the data. And that's where Apache Beam comes in. Basically, it allows you to do it in a distributed manner. So if the data set is big, it scales as well. So that's the analysis step. And then in the transform step, you basically have these numbers. These are just vectors or just numbers that you can use to do the actual transformation. And these transformations is just instance by instance. You don't need any calculations over some sets. So the nice thing is that you can use batches here, or you can just use it one by one. And it's basically abstracted away for you. Okay, so if you look a bit closer again to what you actually are doing in this analysis step, it's just calculating the orange things. So, and there you can use Apache Beam to do this, and you have like all these predefined functions for you, so that on the right side you have everything you need to do the actual transformation. Okay, so what might be relevant here is to know what you can do with these preprocessing functions. If you can do anything, then basically all problems are solved. So, because then you can just use TensorFlow transform for everything. It's quite extensive already, so you can do a lot, but there are some limitations. So basically, what you can do is you can use all TensorFlow ops and predefined TensorFlow transform functions, or you can write your own. What this means is, if you look, for instance, at a few examples, you can do a lot of scaling. So the scale to 0 z-score. You can just normalize. You have all of these options available that are implemented for you. You can implement them yourself. Then you have the bag of words. So basically with the vocabularies to look up word embeddings and stuff like this. You can use n-grams. You can, all of these are just implemented for you. For the bucketization, you also have a lot of options. And then for feature crosses as well. So for the strings that you want to combine different elements, they can also just concatenate them. So that's already doing a lot. What's also nice is that if you have some specific problem in which you do like some stacking of models, let's say you have some time series of sensor values, and you have a frequency of a few seconds, for instance. There you have a model that basically for every minute does a calculation of, okay, this was in rest, and then for every minute it does an aggregation every hour, and every hour to every day, for instance. This is also very nice for this, because basically what you can do is you can also apply a saved model, a TensorFlow model, as a preprocessing function using TensorFlow Transform. So then you can basically change your underlying model and just retrain the whole thing with that model without a lot of overhead that you need to take care of. Okay. So that was like really quickly what it looks like. I think it's very useful to also get an example of how you can use it. And for that example, I want to talk about the digital twins. So basically, it's the idea is to simulate some kind of device or a machine using log data to predict the outputs based on its inputs. So that you can use this model, this digital twin, to try new things. So for instance, if you want to see if this plane crashes, you don't want to test it out, you just want to simulate that first. It's a bad example. So yeah, basically, yeah, that's the whole idea, and we want to use TensorFlow Transform for this. So yeah, I'll use the left side, just showing like different elements of the figure to show how it looks in code. And I want to illustrate with this code, with this example, why it's useful. So specifically from our side, if you were doing this, this digital twins, there's typically we need a model for every single machine separately, but the models look, but the logs of the data look very similar. So we want to have some structured way to reproduce the same thing on different data sets. So that's the first requirement. And then secondly, typically we have lots of logs, and we want to do it in a distributed way. So that's again a checkpoint for TensorFlow Transform. And then the code reuse. So the thing that I wanted, what I mentioned, that basically you can, you don't have to write your own preprocessing separately at inference time. So those things we check. And if we go like on a very specific example, this is one from a blog post I wrote, and it's basically on a cookie dough machine. And the idea is that we have just CSV files of logs, and we have two kind of logs. So basically, the one on the top is the inputs, and the one on the bottom is the outputs. So what we have on the top is stuff that goes in, like the mass of the butter, sugar, the humidity, just like the basic description of what goes in. And then on the right, we have some parameters that we can tweak. So for instance, the heating time, mixing speed, and mixing time. So basically, we have these things that we can tune, and we have these things that are just the inputs. And then for every of these example inputs, we have measured outputs saying, okay, this is the total volume, this was the total output temperature, humidity, the energy that we used, and then the problems that this batch has caused. So the whole idea of this example is to basically, for every line on the top, we want to predict the line on the bottom. So that's basically the idea. So yeah, with that, I hope that's a bit clear what we're trying to do. So if I go into like the code to do this, so if you look at the figure, the top just describes your raw data sets. So this is something that we construct in Apache Beam. So basically, it's just reading the two data sets in, so the two CSV files, and then basically just joining them together with the Google by key and just removing the key. And this way, we end up with one row with just one batch with inputs and outputs in one coherent format. So that's the first step. We just constructed the raw data. It has nothing to do with TensorFlow Transform. It's just basic Python Apache Beam. Okay, so now it's the actual only not boilerplate stuff that you need to know if you want to use TensorFlow. This is the actual construction of the preprocessing function. So this is not something you can reuse between different examples, because it's basically defining what you want to do as the preprocessing. And in this example, I'm not sure if it's clear. Yeah, okay. So basically here I just describe what are the outputs. It's a dictionary of the outputs based on the dictionary of the inputs. And I just put a few of those options in there so you can just take a look. So for instance, we have like a vocabulary saying, okay, this is more categorical variable, saying this is the mixing speeds, slow, fast, stuff like this. So that basically we can use the number, the category ID of this. Then we have just stuff that we can pass through, like the button mass itself. Then we have some normalization in there. And then finally, I think we have also some regex checks. So basically detecting if there are words that we are observing in some string at the end. So basically the problems, this would be like good if we can find classes in there, like stuff like there is a lot of chunks in there. There's too much, too little. So stuff that we can basically with regex just extract away from that. So basically that's it that we want to transform. And you'll see here we have some stuff that basically doesn't need any analysis steps, so we can just pass it through. And some stuff like the normalization or the vocabulary stuff, we need an analysis step in order to do the actual transformation. So but basically this is the only code you need to write yourself to do the pre-processing. So with this function that we have defined, so this is the thing on the top, saying, okay, using the APIs to define what the preprocessing means. And this is again then more boilerplate. It's just saying, okay, with this preprocessing function that you have defined, now just analyze and transform it. So this is this step. So this is just the standard TensorFlow transform functionalities that you can use. And it just says, okay, construct the dataset, the raw dataset. So here, the only thing you need to add is, so next to the actual dataset, you need to define the metadata. So we can say, okay, it's like this format of, we have 5 columns, for instance, in there. We need to define that. And then we can just call the analyze and transform dataset function from TensorFlow transform, which will take in the raw dataset and basically return the transform datasets and the function, the preprocessing function that it calculated for you. So we calculated for you, I mean, it did the analysis step. So you have like your materialized preprocessing function with the numbers in there. So that's that. You could also do it like in 2 separate steps, but it's like very convenient if you just have one line. And basically then the output you get is the transformed data. And again, sorry, the transformed data set is again a combination of the actual data and then the metadata that describes how it looks. So that's the whole thing that the Apache Beam running thing is doing for you. So then we basically have our transformed data sets. So this one, so basically, the transformed data set is this one here, the process data, or something in between, and then the transform function is something linked to the graph. So, but to actually materialize it, to actually go to the transformed data set and actual function, you still need to write it somewhere. You need to serialize it. So this is again just basic Apache Beam codes saying, okay, take into define the code here again based on the metadata, and then write it as TensorFlow records. So this is something you can do in any Apache Beam code. You don't need any TensorFlow transform for that. So the outputs that we have seen before, you can just write it as TensorFlow records. And then the TensorFlow function, the transform function that was materialized, you can also write it somewhere to a directory that you want. So that's that. So basically now we have the materialized thing that TensorFlow transform did. And that's basically it from the TensorFlow transform side, because it's materialized your data, and you have the function that did all the calculations for you. And now we just want to use it. So during the TensorFlow stuff, so it's not linked to Apache Beam anymore. If you want to train on that data, on the left side, I'm just showing like how to do the model training. So what you'll see is it's just standard TensorFlow codes. So you define the input, so you need to define where it needs to read the TensorFlow records. And then you can just use your model, your estimator, to train on that. And that's just the training, so you don't need to include any TensorFlow transform at all in that stuff. And then the second one is to, with that trained model, you want to export it so that at inference time, you also include the preprocessing function. So that's TensorFlow graph that was constructed by TensorFlow Transform. You want to concatenate it. So that's like really the main goal, and that you don't have to rewrite everything there. And this is just a few lines of code. So what it does here, it's since the version 0.8, I think, for TensorFlow Transform. It has this nice wrapper, the TensorFlow Transform output, and which you can just say, okay, this is the directory which I used to write out the TensorFlow graph. It's located here, and then we can basically use this place here to construct the input function that is used in TensorFlow to do the preprocessing there. So we can just say, okay, build serving input function using this tf.Transform output helper. So use this. So this is just all standards. And then you can export it, exporting the model, the estimator, together with the serving input function as one whole, and that's it. So then we have basically one big TensorFlow graph that is a concatenation of the preprocessing and the model itself. The only thing you need to do here specifically was the build serving input function, but this is again like boilerplate since it doesn't have, it's basically really standard. You don't need to rewrite it every time you were using this. It's basically defining, this is the stuff on the right, defining how the TensorFlow Transform is doing what it does. And yeah, if I just summarize it, it says, okay, look at the inputs that you give it, so the metadata of the inputs, and then load the stuff from the model wrapper, and these are the outputs, and then you say, these are the transformation that needs to be done. So and that's that. So you can, the stuff on the right, you don't have to rewrite every time. It's basically always the same. All right, so now we basically have this stored thing called basically the TF graph that's the concatenation of the preprocessing and actual model, which we can just deploy using TensorFlow serving or ML engine. So when that's from our side, it was the cool thing that we could now just use ML engine or just a service that does all the preprocessing all at once. So to do this, we basically just call we have these two commands just saying, make this model version available. And with that, we basically constructed an API on the ML engine side that we can use, and it does auto-scaling for you. So it's very neat. It does all the things together. So then on the left, you can see how to use this API that basically does the whole thing for you. So that's basically it, I think. So that was the demo of it's really an example of what you can do with it. If you want to go a bit deeper into that, the blog post, you can find it here. I think the slides will probably be shared anyway, so you can reach that. And if you want to use the code, I've also put a link to the GitHub repo, and which has already a small data set you can use, and you can basically start from that. So with that, please.
In terms of until you have deployed the model in ML Engine, everything before was actually submitting a big job, right?
Yeah.
Is that okay?
So it's this thing doesn't include any ML Engine threading necessarily. It's optional. Yeah.
Sure. Thank you. But can you also do that, or is?
Yes. Yeah. So basically, all the preprocessing stuff. This is where you need Apache Beam. So it's always running in Apache Beam. It's constructed in TF records, and then only the training itself. This is something you can run, wherever you want.
Mm-hmm. Can you actually embed within Beam TensorFlow to actually do the training there, or you probably will split that in different?
No, it's split. So
okay.
basically, the Beam stuff, what it does is constructs the TF records only.
Sure.
So it's just the raw input data.
Okay. Cool.
But in the code, I also put it here. So if you want to play with it, basically all the stuff in here, you can either run it locally or in the cloud.
Cool.
So if you want, you can do the training locally. If you want, you can the training in the cloud. It's just like with a very simple switch.
Thank you.
Any other questions?
So for the training part, if you're running through several epochs and several iterations in each epoch, how do you do that? So do you have iterative streams or something like that?
Sorry, could you repeat that last part?
How do you do the iterations, multiple iterations
Yeah.
for any deep learning training?
Okay, yeah, so this is not linked to the TensorFlow transform. So basically here we have the TF records. So typically what we always did before TensorFlow transform as well is basically from the raw datasets, which could be pictures or whatever they are, we basically first make TF records, which is like a binary format that's optimal for TensorFlow training. And thereon we just iterate over that dataset. So yeah, please.
So it's only for images?
No, sorry. It's like a very specific example. So just what I wanted to share is like the fact if you take in some input data, it can be either like JSON, CSV files, or it's pictures, or it's whatever it might be. What we'll typically do is do the pre-processing at batch in just one batch, the whole thing together. And the only output that we have is the TensorFlow records. And this is the only thing we look at during the training, so then we can iterate on it.
So this only works for the batch processing mode right now, is that right?
The training is always in batch, right? So it's for training time, it's in batch. And if it's trained, then you can use it at inference really on the streaming inputs or whatever. Yeah.
You seem to have split into two parts. So you are putting the output of Beam to this transform output, and then you're reading that in for the TensorFlow process itself.
Yeah.
Do you have to do that, or is there a more seamless way of doing things?
That's a good question. So basically, yeah, I think the question is why aren't we using the raw data during training immediately, right? Yeah. So yeah, I think it depends a little bit. In our specific cases, we always have like a lot of transformations to do on the raw data, which means that we need to have a lot of compute time as well just to do this. So one option is to, for instance, use the dataset API from Google, from TensorFlow, to basically automate that queuing part, so you don't have this hard dependency. But the major problem is that you don't want to have the dependency between the TensorFlow training, which also need compute, and then the computation of the pre-processing. So what we typically do is just cut it in half, and then we can have the one thing running massively distributed, and the other thing depending on where it needs to run. So we don't have this dependency that we need to optimize. So if it's possible, we always try to split it, and then it suffices. Also for the analysis part, you need the complete loop over the whole data set. So this you cannot also do if you're just looking at one at a time. Sorry, maybe just one more thing. So the analysis part you cannot do, but you could actually do during the training, you could use the constructed TF graph to do the pre-processing on the raw data set directly. Because this part is just TensorFlow stuff, so you can actually use it with other things to work immediately on the raw data, also during training. So it is possible, but as an examples, we first constructed TF graphs, the TF records. Yeah. Yes?
Yeah. So imagine I need to look up some data. Can I actually use tf.Transform to have a side input or even call an external API?
Yes, so you have two options for that. So basically, we either say, and if you look at the codes, this is part of the processing as well, right? So this is also stuff that's not TensorFlow transform related. So you could say, if you need to do the lookups, you could do it just in Apache Beam without the TensorFlow transform in there. So that would be the easiest way to do it, and then you can do it. Otherwise, you have the. Sorry, I want to go back to the other slides. You could look into this thing on the left and on the right. So if you go a bit deeper, then you could also write your own TensorFlow transform operations. And the thing is that you can for the stuff on the left, so with the analysis tab, you can do whatever you want. So you can write any Python code in there, because it just needs to be running on Beam, but that's the only requirement. Only for the right side, it needs to be in TensorFlow. So if you say, in this analysis tab, I want to write a very specific one that does a lookup, I won't say it's like a recommended thing, or like, but in theory, you could do it.
Cool. Thank you.
Anyone else? Cool. Thank you so much, Matthias.
All right.